50 feet away from you is the base of the tallest mountain in the world, Mount Everest. Although you have dreamed of climbing this mountain for years, trekking up it will be mentally and physically taxing. Along the way, you will face numerous challenges, like a reduction in oxygen, grueling cold temperatures, and vertical inclines close to 90 degrees. Every organism, including the mountain climber, must maintain a certain internal environment when external conditions are fluctuating. Homeostasis is an organism's ability to maintain these internal conditions despite external changes. Body temperature is one of the most common internal conditions an organism must maintain. The body temperature of a human is set at 98.6 degrees Fahrenheit. Its internal temperature must remain around 98.6 degrees. Thermoregulation is the way an organism maintains this set temperature. We can define two types of organisms based on the way they control body temperature. Endotherms, such as birds and mammals, rely mostly on metabolism to maintain their temperature. An eagle, soaring high in the sky, can keep its internal temperature relatively constant without any help. But ectotherms, such as frogs and snakes, rely on environmental sources to regulate internal temperature. For example, when the sun is beating down upon a frog, it might hop under a tree. Amphibians, several species of fish, and other invertebrates are also considered ectotherms because of their internal temperature fluctuations. Besides temperature regulation, organisms are tasked with the regulation of blood glucose levels. When you haven't eaten in a while, your glucose level will be very low. To combat this and maintain homeostasis, the pancreas releases glucagon, which stimulates the formation of glucose. These new glucose molecules are used to increase blood sugar levels. On the other hand, if too much glucose is present in the blood, the pancreas secretes insulin to remove the sugar. Diabetes is a condition that results when the body cannot maintain its blood glucose levels. Traveling back to Mount Everest, we feel the icy cold air hitting our skin like needles. To detect freezing temperatures, a mammal uses receptors in the hypothalamus as temperature sensors. A sensor detects the stimuli, other parts of the organism react, and ideally this causes our bodies to reestablish a set point. One response the climber might have to extreme Arctic temperatures on Mount Everest is the reduction of blood flow to parts of the body not holding an essential organ, like fingers and toes. Now, let's explore different mechanisms of maintaining homeostasis using feedback loops. Simply stated, a negative feedback loop reduces the stimulus and a positive feedback loop amplifies the stimulus. The reduction of blood flow to certain areas of the body, in our last example, is a negative feedback loop. By reducing the blood flow to non-essential organs, the body retains heat and thus reduces the cold stimulus. Most biological mechanisms of feedback are negative, but think of blood clotting as an example of positive feedback. When a blood vessel is damaged, platelets adhere at the site of injury. After adhesion, these platelets release chemicals that attract more platelets and enable the formation of a blood clot. We have learned that homeostasis is the ability of an organism to maintain internal conditions despite environmental changes. Organisms use positive and negative feedback loops and other internal systems to maintain homeostasis every day. Even though most of us will never reach Everest, we have reached the peak of knowledge on homeostasis.